So starting next fall, we'll have a workshop for anybody who's interested in learning. But at any rate, the tissues that you look at will have been prepared for viewing under the microscope. And by preparing the tissue so that we can see it, then artificial characteristics are introduced. They're called artifacts. You know, when a certain structure or something is caused by the processing, that's called an artifact. Okay. So one of the ways that tissues are prepared is by being stained with a dye that helps us see the tissue better under the microscope. So when you're looking at any of the different tissues, you're looking for some type of color that will indicate the tissue itself. I'm going to erase these. We'll talk about each of these four categories in greater detail when we come to it. All right, now, these transparencies and pictures and books and other learning aids that we will have, we'll have charts of certain types of tissues and so on. They're good to introduce you to what the tissue looks like, but they're too good, okay? They're not going to be what you will see under your microscopes. Now, so when you're looking for epithelial tissues, one of the general characteristics of epithelial tissues is that it's next to a free space. The free space won't stain. So, you know, you can identify the free space because it's going to be colorless, like this, for example, or this, or this. All right. Another characteristic of epithelial tissues is that the cells will be very, very close together. And you would see very little space between cells, very little extracellular space between cells. Another characteristic of epithelial tissues is that the epithelial tissues will be located between the free space, this columnless region, for example, here, between the free space and a boundary called a basal membrane, okay? The basal membrane is made up of different molecules that are produced and secreted by both the epithelial tissues on one side and connective tissues on the other side. The epithelial tissues will produce and release certain proteins and stuff like that, whereas the connective tissue underneath will produce and secrete different kinds of protein fibers, like collagen fibers that you might hear of on commercials, reticular fibers, and elastic fibers that will allow the skin to snap back and whatever. In reality, the basement membrane will look like a line of demarcation. You know, in other words, a line where you got one type of tissue and then all of a sudden you got something entirely different next to that. And so notice you got this kind of tissue and about approximately here, you got something entirely different. So that boundary is where we would imagine the basement membrane to be. Okay. On the other side of the basement membrane, later we will learn will be connective tissue.
Is it basement or what did you call it?
Basement membrane. Okay. The basement membrane, like downstairs. Okay. I might have said basal membrane, but there is something called a basal lamina.
Okay, I knew.
That's different from the basement membrane. Okay, I probably said both. Okay. The basement membrane. All right. When different illustrations label it, they'll use film to the basement membrane. Okay, now. So, when you're looking at all of the various, when you're considering all four types of tissues, muscle tissues, connective tissues, nervous tissue, all right, then in epithelial tissues, another identifying feature will be that you won't find blood vessels within epithelial tissues. Blood vessels are deeper beneath the surface of the tissue and would be in the connective tissue layer beneath it. All right. So let's look at some of these examples and see if we can identify the basement membrane and see if we can identify the free space. All right, let's do an easier one first. One reason that these illustrations are too perfect is that they're usually at a greater magnification of what we will be looking at. You're going to study all of our tissues at 400x. All right? So if you want a final magnification of 400x, does that mean that you're going to use the scanning lens, the low power lens, the high power lens, or the oil immersion lens? Remember that from before? All right. So we would have looked at the microscope if we were in the lab. And we would use the high power lens, okay? Which by itself will magnify it 40 times. It will magnify the image 40 times. But our microscopes are compound microscopes. We use two sets of lenses to view the specimen. We use one set of lenses that are built into the eyepieces, okay? And these are called ocular lenses. They magnified the object 10 times themselves, okay? If your microscope has one ocular lens, like the ones in 3411, that's called a monocular microscope. If it has two ocular lenses, that's called a binocular microscope. We're using the binoculars in 3425. Compound microscope means that the image, the final image is based upon the magnification of the ocular lenses times the magnification of the objective lenses, okay? And so if our objective lens magnifies 40 times normal size itself, then when we're viewing the specimen using that 40x lens, then the final magnification will be 40 times 10, or 400x. Okay, so we're going to view everything using that high-powered lens. It's going to have a blue ring around it with blueprint, and you will see a big 40 on it, or even 40x. All right.